Okay, here we go. Today is classwork 9, surface area and volume of spheres. So to understand the formula for the surface area of a sphere, meaning the area around the outside of a sphere, think about a baseball. What if we remove the cover from a baseball or a softball? You're going to end up with two sort of figure-8 looking pieces of material. The surface area of a baseball is sewn from two congruent shapes, each of which resemble two joined circles. So the entire covering of the baseball consists of 4 circles, each with radius r. If we now know that the area of a circle with radius r is pi r squared, the covering of that baseball, the covering of the sphere, can be approximated by 4 pi r squared. So this is the formula that we're going to use for the surface area of a sphere. So I'll write it again. Surface area of a sphere is 4 circles, which equals 4 pi r squared. So here, we're going to find the surface area of each of these two spheres. Plug into the formula for the first one. Surface area equals 4 pi 8 squared. And then we can plug it all into our calculator and get approximate, or take 64 and multiply it by 4. That's what I did. And I got surface area is 256 pi inches cubed. For the next one, you're going to be working backward to go forward. So to work backward, remember, circumference is 2 pi r. So we set 12 pi equal to 2 pi r. Divide by 2 pi. We see the pi's cancel. We see the 2's cancel. And on the left-hand side, the pi's cancel. So 2 goes into 12 6 times. Our radius equals 6. Now we plug it into the formula. Surface area is 4 pi 6 squared. 36 times 4 is 144. So our surface area is 144 pi feet cubed. For the next one, we're just working backward when given the surface area to find the radius. So if I know that the surface area is 4 pi r squared, and I know that they've given me the surface area of 20.25 pi, 20.25 pi equals 4 pi r squared. I divide both sides by 4 pi. Pi's cancel, 4's cancel, and the pi's cancel on the left side. So plugging into my calculator, I'm going to get r squared is 5.0625. So what do I do to find the radius? I take the square root of both sides, of course. So now plugging all of that under the radical, the radius is going to equal 2.25 centimeters. All right, here we go. Last goofy video, so I have to unshare and then reshare. So here we go. share. Good morning, everybody. Share screen. Here's our video. Share and hello and share screen back here. Sorry that there wasn't any jazzy music there. All right. This isn't the ideal video for this that I wanted to convey, but hopefully you get the idea. If we were in class, we would have done multiple experiments with these little green shapes and not used water, but we used rice. So here we go. Imagine a cylinder. So circular base, circular top, and then there's some amount of height. The volume of a cylinder is that pi r squared h. So remember, the volume of the cylinder is the area of the circle base times the height. Now, if we had a sphere that had the same height as a cylinder, so imagine you put the sphere right next to the cylinder and they were the same height, then wouldn't the height of the cylinder just be the diameter of the circle? So we know diameter to be 2 radii. So our height, which would be the diameter of the sphere, is actually 2 radii. We're going to take this 2r right here and substitute it in here. So now I'm going to rewrite that. Volume equals, I'll put my 2 in front, pi, radius squared times radius cubed, h. Sorry, no h. There we go. So if we have a sphere that's the same height as our cylinder, we can substitute in 2 radii for the height. Volume of a cone. Well, remember, the volume of the cone is the volume of the cylinder divided by 3. So we could take the volume of our cylinder, which is in red above, and just divide that by 3. So we could say that the volume of the cone equals 2 pi r cubed divided by 3. And from the video, this is what I wanted you to see. How many cones did it take to fill the sphere? Well, it took 2 cones. So couldn't we just double this red formula here, volume of cone that we're looking at? So volume of the sphere equals 2 times the volume of the cone, 2 pi r cubed divided by 3. We could just double that, correct? All right, so let's write our formulas. Surface area of a sphere is about baseball. It takes 4 areas to cover the whole baseball. So our surface area of a sphere is 4 pi r squared. And our volume of a sphere is 2 cones. And so our volume of a sphere is going to be 4 pi r cubed divided by 3. So let's look at these in action. Let's do some of these problems. First one, find the volume of this for each sphere here. We're just going to plug in volume equals 4 pi h cubed divided by 3. 4 pi r cubed divided by 3. For the volume, I'm just going to plug the whole thing into my calculator. 2,144.66 meters cubed. The only trick in part B is you have to see that they gave you the diameter, not the radius. So we know here the radius equals 11. So now plug in volume 4 pi 11 cubed divided by 3, or plugging into the magic calculator machine, volume is 5,575.28 yards cubed. For the third one, they gave us the circumference. When we work backward, remember, circumference is 2 pi r. Set 2 pi r equal to 20 pi, and we get a radius equal to 10. So volume equals 4 pi 10 cubed divided by 3. Volume equals 4,188.79 millimeters cubed.